Welcome Algebra 2. This is 11-3, Probability of Multiple Events. An essential question is, what is the difference between independent and dependent events? Let's begin. So an independent event is an event that doesn't affect, these are events that don't affect each other. So if I picked a random student from my class, and then picked a random student from Mr. Brophy's class, these would be independent events because they're different sets of students, and the pick of one is not going to affect the pick of another. Now, dependent event are events that affect each other. So if I picked a random student from my class, then I picked a second student from my class. That second student depends on the first because the first student can't be picked for the second pick. They've already been picked. They're gone from the choices. So the first pick removed a choice, and then the second pick has just a different pool of kids to choose from. So that's why it's dependent on the first. So if I ask questions, are each of these dependent or independent events? So if I roll a number cube, then I spin a spinner. So number cube is a dice. So if I roll a die and then I spin a spinner, are these independent or dependent? They're definitely independent because the two events are with completely different objects, and whatever you get on the number cube doesn't change what you get on the spinner. Two different actions. Now if I pick one flashcard, then another from a stack of 30 flashcards, are these independent or dependent? These are definitely dependent because they're being picked from the same stack of flashcards. So when you pick the first flashcard, now you only have for the second pick. So in the first pick, you got 30 to choose from. The second pick, you only have 29 to choose from because the first one's gone. So in which cards are in there will depend on what you picked in the first pick. That's why they are dependent. Now, other things about independent events. If two events, A and B, are independent events, so some event A and some event B, then P, this notation here is for probability notation. We saw that last time. So the probability of the event A happening and B happening, so that means both happen, is the probability of A times the probability of B. You multiply here. So we're going to multiply the probability of two independent events if we want to see what are the chances of both happening. So for this example, at a picnic, there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If I grab a drink and a bag of chips without looking, what is the probability that you get a diet drink and a fat-free chip? So there's two events. So probability of event A, and then there's probability of event B. Well, your event A in this case is going to be probability that you get, we're going to do the probability of drinks. So probability of diet drink. And what's the probability that you pick up a diet drink? Well, there are 10 diet drinks, and there are going to be 10 plus 5, 15 drinks total. So that's going to equal 2 over 3, 10/15ths or 2/3. Now, probability of event B, the second event, that's going to be probability of getting fat-free chips. So fat-free chips. And in this case, for fat-free chips, there are 8 bags of fat-free chips, and divided by 8 plus 12, 20 bags total. And that's going to reduce by 4. That's going to reduce to 2 over 5, so 2/5. So the probability that both events happening are going to be 2/3. So let's write that. Probability of both, let's say diet and fat-free, are going to be 2/3 times 2/5. And multiplying that out, nothing reduces, so it'll be 4/15. That is your overall probability. All right. Mutually exclusive events. So these are two events that cannot happen at the same time. So it's just there's no possible way in the real world that they can happen. They are both exclusive of each other. So one example of this, if you roll a standard number cube, are the events mutually exclusive? Explain. So these are two cases of this. Rolling a 2 and rolling a 3. Are these mutually exclusive? Yes, they are, because you only can roll one. So you can only roll a number 1 through 6. You can't roll a 2 and roll a 3 with the same die. It's going to be either the 2 or it's a 3 or some other number. Now, so I'm going to say yes, only one number is rolled. So rolling an even number and a multiple of 3. Well, what are all the even numbers on a standard number dice? That's 1 through 6, 2, 4, and 6. And multiples of 3 on the number die are 3 and 6. Notice there's one number that is the same in this case, and that is 6. It's on both of those events happening. So are these mutually exclusive? No, because of 6. So if you rolled a 6, it is an even number and it's a multiple of 3. These are not these you can roll an even number and you can roll a number that's a multiple of 3, so these are not mutually exclusive. Probability of A or B. So not last time we talked about probability of two events happening, A and B. This is A or B. So A happens or B happens. So the probability for the formula of A or B is the probability A plus the probability of B minus the probability of A and B. And there's another case. If they are mutually exclusive events, the probability of A or B is the probability of A plus the probability of B, if they are mutually exclusive. So let's look at an example of this. At your high school, a student can take one foreign language each term. About 37% of students take Spanish and 15% take French. What is the probability that a student chosen at random is taking Spanish or French? So the probability of Spanish or French. All right, so if I'm following that formula in that last case, it's going to be, and now, are they mutually exclusive? Yes. It's because you only take one foreign language. You can't take Spanish and French. So the formula for that is going to be the probability of A plus the probability of B. So probability, so this will equal probability of Spanish plus the probability of French. What's the probability of Spanish? It is going to be 37%. What's the probability of French? 15%. If you add those up, you will get a total probability of 52%. And that is your answer. Moving on. So we got another example here. Suppose you reach into a dish and select a token at random. What is the probability that the token is round or green? So probability of round or green. Now in the case of this dish, are these events mutually exclusive, round and green? No, they're not, because something can be round and green. So I'm going to have to follow this formula. If they are not mutually exclusive. So it's the probability of A happening round plus the probability of B happening green minus the probability of both happening round and green. So the probability of round happening is going to be, how many are round here? There are 1, 2, 3, 4, 5 round. And how many items total? 1, 2, 3, 4, 5, 6, 7, 8. There's 9 total. So 5/9. And it would be plus the probability of greens. Well, you have 3, so it would be 3/9. Minus round and green. So round and green is going to be 5/9 times 3/9, which is the same thing as 1/3. So let's combine terms. Let's simplify this. So these two fractions right here are going to add up to 8/9. Those two combined, 5 plus 3 is 8/9. Now this is going to be subtracting 5 over 27. I want to make these common denominators, so I'm going to multiply the left fraction by 3 over 3. So you're going to get 24 27ths minus 5 27ths, which will get you 19 27ths. And that will be your answer. Let's try some example. Pause the video. Alright, same token question. Suppose you select a token at random from the dish above. What is each probability? Token is square or red, so probability of square or red. So these are not mutually exclusive, so I can go the probability of the square plus probability of red minus probability of the and. Square and red. So probability that something square is going to, there's 9 again, so it's going to be 3/9, plus it's red, and that's going to be 3/9. 1, 2, 3 red. And then square and red is going to be multiplying those together. So minus 3/9 times 3/9 will be, that's 1/3 times 1/3, which is 1/9. So I'm going to add these fractions up. They're all the same denominator. So that's going to be 3 plus 3 minus 1 will be 5/9. That's your answer. All right, which makes sense because there's 9 on here, and square or red is 1, 2, 3, 4, 5. So 5 items out of that total. Token is green or square. So probability of green or square. So in this case, probability of green plus probability of square minus probability of green and square. So green is going to be 3/9 plus probability of squares are 3, so 3/9 minus multiplying that, it's going to be 1/9. So it's going to be the same probability as last one, 5/9. That's it.